Hi folks, we are officially starting the first chapter of calculus. Section 1.1 is all about functions. A lot of these terms are terms that you're going to be relatively familiar with, but we're going to be talking about, what a function actually is, what domains and ranges of functions actually look like. We're going to go through examples of something called a piecewise function, but if you understand how to work with functions, if you understand what f of x means, if you understand how to plug things into functions, then you should be okay. So we're actually going to jump right into the notes. I'm going to walk my way through the notes with you. So hopefully you kind of understand, you get the feel for what these things actually mean. Okay. So this is section 1.1. And this is all about functions. All right. So let's start off just by the definition of what functions actually are. So when we talk about what functions actually are, a function is something that's related together by something. So a function is a relation. Oh wow, this handwriting is bad. A function is a relation that maps each x to exactly one y value. So it's going to relate something to exactly one y. That means that for every single time I plug in an x value, I am going to get exactly one y value back. Okay, so every time I plug in something for x, I'm going to get exactly one thing for y. There's no possible way that I can plug something in for x and get two different answers, right? Like if I just look at a normal equation, y equals x plus 2, there's no way that I can plug something in for x and get two different values for y, right? There's no number that gets plugged in here that gives me two outputs for y. There's no possible way that that happens, okay? So a function is a relation that maps exactly two things together, okay? You're also going to hear the words or see the words possibly at some point called a relation and a rule. And I'm not going to get too far into those. A relation is just when numbers are put together in a pair, like there's an x and there's a y, and there's no rhyme or reason to it. A function, there is a rhyme or reason to it, and that's the stuff that we're going to be really, really careful of. Okay, so that's what I want you to kind of think about. So a function is very important because it maps one x to one y. So a lot of the ways that you're going to see this is if I have something that looks like this, if I have an x and a y, and then I have some random numbers in there for x and some random numbers in there for y, every single one of these is going to get mapped to exactly one y value. Okay, notice how there's one line going from certain things. Now there can be different things that look like this, like maybe two different, maybe two different x values map a different y value, right? So like if I think of something like y equals x squared, if I look at my x values and I look at my y values, if I have something like -1 and 0 and +1, then I could have the values over in y of 0 and 1. -1 takes me to this, so does +1, but 0 goes to this. So notice there's two lines going to the same y. That's fine. These are both definitions of a function because one x gives one y. The thing that is not going to happen is I have something that looks like this. There's no possible way that I could have like different x values like this. There's no possible way that I could get one number to produce two different things. So if you notice the difference between this picture and this picture, in this one, there are two lines going to one y value. In this one, there's one x going to two different y values. No equation exists that you could plug in two and get two different answers for your equation when you're done. So that's never, ever going to happen. Okay. Continuing on with some definitions, we're going to talk about the domain, which we know that the domain is all possible x values. And in calculus, it's going to be really important that we call this or remember this as the independent variable. And we also have our range. And remember, the range is the possible y values. And this one is the dependent variable. Because whenever you have a function, the number that you're allowed to change is x. you plug in whatever you want to for x, and then it's going to produce something to give you the value of y. So the y value depends on what you plug in for your x value. Should be pretty straightforward, okay? So those are the two big things that we want to talk about with definitions: domain and range, and then functions, okay? So now what we're going to do is we're just going to get into kind of some notation to make sure that we understand what's going on with these, okay? So our notation, so this is a big section. We need to make sure we understand notation. If I have something that looks like this, f of x equals x squared plus 3x. If I have something that just looks like this, the actual variable x is what the input is. That's the variable that we're putting things in for, right? We are putting things in for x. That's something that's going to be pretty important, okay? We also have something called the output. F of x is the output. We put a number in for x, we get a number out when we get f of x. That's really the same thing as what like y is, right? Because y and f of x are interchangeable. I could write this as f of x, or I could write this as y equals x squared plus 3x, and it means the exact same thing. We're going to use this one constantly though, because that's the easiest way for us to understand when we're plugging something in, okay? And then finally, the last thing is x squared minus 3x or plus 3x. This thing is called the rule. So that thing is called the rule. Okay, so we have our input, we have our output, and we also have the rule. Everything right here is called the rule, and that's basically what defines the function itself. Okay, so if we look at an example of what this looks like, how we're plugging things in, so on and so forth. If I look at a general function where I have like f of x equals 7 minus 3x, if I want you to find f of 0, this is literally saying I want you to find the value of function f at point 0. So I'm going to take my function and I'm just going to plug 0 in for x. I always like to put things in parentheses when I'm plugging something in so I know that I've actually replaced it. So this thing is going to end up being 7. Okay. If I want to try something a little bit nicer, or I guess maybe something a little bit more challenging, I should say, what if I plug in 7/3? So I could do 7 minus 3 times 7/3, and then I end up getting 7 minus 3 over 3 times 7/3 is the same thing as 7. So I end up getting 0. Okay, and now the thing that we can do in calculus that we didn't really do so much in algebra 2 is we can plug in different variables and different expressions. So we can plug in a different rule to this thing. So nothing changes. We've just plugged in several different things into the x. We're going to do the same exact thing here. So this is like saying 7 minus 3 times q plus 2. And then we would just simplify. So we'd get 7 minus 3q. And then remember, you have to distribute negatives. So negative 3 times 2 is negative 6. So then I'm going to end up with 7 minus 6 is 1. So 1 minus 3q. Okay? So that should be pretty straightforward. But I want to go through an example that's just a touch more challenging so that way we understand how we can work through these in a different way. So if I have something, and I can use any function name, and I can use any variable that I want. So I could say something like q of t. This just means we have a function, it's called q, and it means that our variable is t, okay? So I'm gonna write this function down. So let's say we have 2t to the second power plus 3 over t squared. All right, it's just a different rule, it's just a different function, it's just different stuff. Now, we could do a whole bunch of things. We could try a bunch of different things, but if we try like q of 2, let's say, I would just plug 2 into this equation. So 2 squared is 4, 2 times 4 is 8, 8 plus 3 is 11, over 2 squared is 4. So q of 2 would just end up being 11 over 4. If I tried to plug in something like this, where it's q of like 0, we should notice that if we plug 0 into here, it doesn't matter what the top looks like, because if it's 0 in the denominator, that means this is going to be undefined. So that thing instantly is going to be undefined, okay? The thing that makes this a lot more challenging is when we have something like this. If I wanted to plug in negative x, so q of negative x, this is where we have to be a lot more careful. So again, where I said I like to plug in parentheses initially, I'm going to put parentheses in everywhere that's really important. I'm also going to replace every single variable t with the variable negative x. So this will end up being negative x squared negative squared is positive, x squared just remains x squared, so it's going to be 2x squared plus 3 over negative x. And I like to move this negative x either out front or up top. Or I'm sorry, the negative. I like to move the negative either out front or up top. It doesn't really make a difference, actually. Hang on, because I forgot to put this here. So now that shouldn't make a difference because I have a negative x squared, and negative x squared will just become positive, and we're done. One thing that people like to do is they like to cancel these two things. You cannot. There's a plus sign in between them, so you can't cancel them, can't do anything with them at all. So don't cancel these, okay? Plugging things in for functions is very straightforward, and you just have to remember that you're plugging things in to every location and then simplifying wherever possible, okay? So that's a really, really important topic that we need to make sure that we're covering, okay? The next thing, and really the last new thing that I want to talk about, because I want to make sure that we understand what's going on, is we have something called like piecewise functions. Okay, now piecewise functions are extremely important and they can be kind of tricky if you don't know what you're doing. So these are called piecewise functions. And basically what's happening is you will have a piece of a function for certain domains, certain areas. So piecewise functions are always represented by something that looks like this. You'll have a big f of x that looks like this, and then you're going to see this little weird little bracket, parenthesis thing, whatever you want to call it. Okay? So then you're going to see a piece of a function, so like maybe x plus 2, and then you might see something that looks like this, where it's like 2x squared plus 20. Now what this looks like, you are given two different functions. So you're saying that one big function is defined by two different rules. And obviously those rules are going to have boundaries. So you have one big function and two different rules, but you have to know when to use those rules. And you're going to have different times. So it would say something like this. It would be x plus 2 when x is less than 1, less than or equal to 1. And then you might say something like this where x is greater than 1. So that means if I'm plugging in an x value that's less than or equal to 1, I have to use this top function. If I have a function that looks like this, where it's greater than 1, then I'm going to use this function. Now, if I look at this on a graph, and I apologize, I'm not going to be able to graph this extremely well, but the function x plus 2 is going to look like this. It's going to go up 2, it's going to have a dot here, and then I'm going to go up one, right one, up one, right one, up one, right one, and I'm going to go down and over the same exact way. So I'm going to have a function that looks like this, right? So now if I have a function that looks like that, I actually can't do that because I'm not going to be able to get rid of it. So I'm going to have a function that looks like this, right? Now that's great. But the thing is, I'm told that this has to stop at 1. So what I have to do is I have to put a dot at 1, and it's going to be a closed dot because this is less than or equal to. And I'm going to erase everything from here because my function is only defined at that spot, okay? My function will only be defined up to that point. Now, the next thing that we like to do, and I'm going to move myself out of the way here for a second. The next thing that we have to do is we have to think about what the parabola looks like here. Now, I know that I'm going to have some parabola that's going to be shifted up 20 units, so I know this isn't accurate, but I'm going to have something that's shifted up however many units, and it's not going to be shifted left or right any, right? So it's just going to be shifted up 20, and it's going to be right at the origin. So that means that I'm going to have a really tall parabola way up over here that looks like this. Move myself out of the way. So I'm going to have a really tall parabola that looks like this. Now again, I can't have two functions line up on top of each other because something we learned a long time ago called the vertical line test. If I were to draw a vertical line up here, it no longer works. There's two y values being mapped from the same x. So if I look at -1, I'm going to have a value here and I'm going to have a value here, and that's not okay. I can't have that happen. So since I can't have that happen, I have to follow the domain that it gives me. And my domain is at +1, and it's going to be an open circle here because it's just greater than. That's why when I draw a vertical line straight down here, it only touches one time because this value doesn't exist for this function, okay? So I'm going to erase this part, and that's what my piecewise function is going to end up looking like. So my piecewise function has two different pieces, but it has two different domains. So now they may ask you a couple different things. I'll put myself back here. So a couple things that it might ask you is it might specifically say, okay, I want you to find the value of f of -2. Now there's a couple things that you have to think about because I'm not just going to plug -2 into both of these because it's not going to be plugged into both. I have to find the domain that fits this value. So if I have -2, -2 is obviously less than or equal to 1, so I'm going to use this. So I'm going to do -2 plus 2, which is equal to 0. If I want something like f of 2, so if I want something like f of 2, I'm going to end up looking here because 2 is bigger than 1, right? So now I'm going to plug 2 into here. So 2 squared is 4, 2 times 4 is 8, plus 20 is 28. The one that could be a little bit tricky is what happens if I ask you for f of 1? If I ask you for f of 1, I'm not really sure which one to use, but this one has an or equal to sign, which means that I have to use the top one. So my value is going to end up being 3. So piecewise functions are really, really easy if you understand domains. If you don't understand domains, that's what makes things more challenging. Okay, so you really have to pay attention to domains when you're using piecewise functions, because if you understand them, great. If you don't understand them, that's where we need to really make sure we're following along. Okay, the last thing that I want to talk about, and the last thing that I want to mention, period, is I want to talk about domains. Domains are super, super important. And really, that's the big thing that we talk about in this section is domains. We don't really talk about range very much because range really isn't usually restricted much. But the domain, we really want to pay attention with domain is restrictions, numbers that we can't plug in. So if I look at something like this, where if I have f of x equals 3x over x plus 5, I want to know, are there any numbers that I can't plug in for x? So I have to look at what spots on here are going to create issues for my function. And right now I can tell immediately that if x equals -5, if x equals -5, I'm instantly going to have an issue because the bottom of my function is undefined now, right? It's 0, so it's undefined. So right now, I would put for my domain all reals except -5. You could put x can't equal -5 because you would assume that it equals everything else. If you wanted to, you could put all reals, but x can't equal -5. It really doesn't make a difference as long as you make note that x can't equal -5 somewhere. Okay. The other type of domain problem that can be kind of challenging is if we have another rule where it's like f of x equals the square root of x plus 4. Now, when we talk about domains, we're basically talking about on a graph. Like what would be possible to be put on a graph? So again, I asked the question, what spots in here make it so that I can't hit the enter button on my calculator? It won't work. So if I look at this, if I take the square root of something, the square root of something has to be positive, right? So that means that in order for me to actually use this or hit the enter button on my calculator, x plus 4 is going to have to be bigger than or equal to 0. It has to be. Because if it's not bigger than or equal to 0, then it can't work, right? So it can't possibly work. So I know that x has to be greater than or equal to -4 in order for me to use my calculator or hit the enter button. Otherwise, it's going to be imaginary. If I were to plug in -5, -5 plus 4 is -1. I can't take the square root of -1. Okay? So that's just something to kind of think about, something to see. So one last example that has to do with plugging things in that I thought would be relatively important. All of the new stuff is kind of done, but one thing that I thought was relatively important is, what if I have a function that looks like this, where it's f of x equals x minus x squared? And I'm asked to do some things, like I'm asked to do some stuff that I need to solve, okay? Now that stuff that I need to make sure that I pay attention to, or the stuff that I need to really understand, is what happens if the question tells me something like this. It tells me to find f of h plus 5 minus f of 5 over h. What if it tells me to find all of these things? So really what it's saying is I need to plug in this thing into this equation once, and then I need to subtract this thing in the equation, and then I need to divide by this thing of the equation. So the first thing I'm going to do is I'm going to plug in f of h plus 5 to see what that thing simplifies down to. So I have to plug in h plus 5 everywhere that I see x. So that's what that looks like. Now, one really important thing that I need you to understand is I can't just square these. This is a review. You need to be able to FOIL this. So this is really saying h plus 5 minus h squared plus 10h plus 25. Now I distribute the negative all the way through, so I have h plus 5 minus h squared minus 10h minus 25. So it's going to be negative h squared plus 9h minus 20. That's what h plus 5 is going to be. Now I have to do the same thing with f of 5. So if I have f of 5, I'm just going to plug in 5 minus 5 squared, which that's nice because I don't really have to do much. This is just going to end up being negative 20, right? And then now what it wants us to do is add this thing and this thing together and divide by h. So I have negative h squared plus 9h minus 20 plus negative 20 over h. So now I simplify as much as I can. So it's going to be h squared plus 9h minus 40 all over h. And I can't really do anything past this very much. Yeah, I can't really do anything past this too much, right? There's not much more that I can do. Oh, actually, hang on. This is where I have my issue. It says minus right there. I should have subtracted. I knew I made a mistake somewhere. I couldn't find it though. So this should say negative h squared plus 9h minus 20 minus negative 20, because that's a minus sign up there. So then minus 20 minus negative 20 will go away. So this will end up looking like this. And then I can simplify it just a touch by factoring an h out. So I can do h times h plus 9 all over h. And this thing will end up simplifying. I'm missing this. So now I'm going to end up with negative h in there. And then it's going to be negative h plus 9. Okay? So that's something that I need to really make sure that I'm paying attention to. I really need to focus on that because I'm allowed to simplify these things. Your ability to simplify is going to become very, very important. Okay? That's what this section kind of discovers, whether or not you have good simplification skills or bad simplification skills. So it's something that we need to really make sure that we're working through. But you have to understand domain, you have to understand range, you have to understand when you can plug things into certain things. That's what this whole section is really bringing to light. How good are you at recognizing plugging things in for domain and range and piecewise functions? How good are you at simplifying? How good are you at understanding and utilizing function notation? Those things are things that we need to really make sure that we understand. So if you have any questions, let me know. I know that this video is long enough as it is, so there will be some questions that you can work through on Google Classroom. So if you have any issues, bring them up and talk to me about them. But for the most part, I think that you guys are going to be all right kind of fighting your way through things. Okay. So again, if you have any questions, let me know. Have a good day.